Welcome, my friends. In this video, we will be discussing probability, including definitions, notation, and calculation. Most of us have an intuitive idea of what probability is, as we hear about it in many different areas of our life. From the weatherman's prediction that there is a 30% chance of rain tomorrow, to a 1 in a million chance of winning the lottery, to an executive's subjective judgment that there is a 90% chance of a business deal being successful. These are all versions of probability, a number between 0 and 1 that describes how likely an event is to occur. Probability is on a scale, with numbers closer to 0 representing less likely events, and probabilities closer to 1 representing more likely events. A probability of 0 means that the event is impossible, and a probability of 1 means that the event is certain to occur. A probability of 0.5 means that there is an equal chance that the event does or does not occur. Probabilities below 0 or greater than 1 aren't defined, and don't really make any sense in the first place. What would it mean for a probability to be -3 or 160%? You can't get any less likely than impossible or more likely than certain. Your statistics professor reserves the right to award negative points for any probabilities on your test that are less than 0 or greater than 1. Capital letters are typically used to represent events in probability, such as the letters capital A, capital B, or capital C. Probability is typically expressed in one of three ways: in decimal form, such as 0, 0.5, 0.75, or 1, in percentage form, such as 0%, 50%, 75%, or 100%, or as a fraction, such as 1/2 or 3/4. All three versions are acceptable ways to express probability. Notationally, we will write the probability of an event by first writing the capital letter P followed by the event in parentheses. So this statement would be read: the probability that event A occurs is equal to 30%. There are many different ways to determine or assign the probability of an event, but we will briefly discuss three. First, there is subjective probability, in which someone uses their intuition, past experience, judgment, or opinion to come up with a probability. This would be like the executive who believes that there is a 90% chance of the business deal being successful. This probability isn't based on data or numbers, but rather experience and judgment, based on similar business dealings encountered in the past. The reliability and accuracy of subjective probabilities are highly dependent on the person determining the probability, and therefore should be viewed skeptically. Many probabilities are based on relative frequency, how frequently the event occurs out of a sample of n observations. The probability can be calculated as f over n, if f is the frequency of the occurrence of the event and n is the sample size. For example, if we flipped a coin 10 times, we might expect to get heads on 50% or 5 out of the 10 flips. But in a sample of size 10, we might not flip exactly 5 heads. We could flip 3 or 4 or some other number. In that case, the estimate of the probability using the relative frequency approach might be slightly off. Thankfully, we can always get a better estimate by taking a larger sample. Sure, getting 4 out of 10 heads wouldn't be all that unlikely if the true probability is 50%, but if we were to flip 1 million coins, and only 40% of those came up heads, then we might start questioning whether or not we have a fair coin. The law of large numbers is the idea that, in the long run, as the sample size increases, relative frequency gets closer and closer to the theoretical or true probability value. Small samples can give us inaccurate probability estimates, but if we take larger samples, we are more likely to get a probability estimate that is accurate. The third type of probability that we will discuss only applies when all outcomes are equally likely. In that case, we can find the probability of an event by taking the number of outcomes in favor of the event divided by the total number of possible outcomes. For example, you might be playing the lottery, where you need to choose a number between 1 and 1 million. If only one number is chosen, you have a 1 in 1 million chance of winning the lottery. There is one outcome favorable to your event of winning the lottery out of the total 1 million possible events or numbers that could be chosen. If you get to choose 5 numbers instead of just 1, your probability of winning becomes 5 out of 1 million. In probability, the sample space includes all possible events in the scope of your statistical experiment. The sum of all probabilities in a sample space must add up to 1, since the sample space encompasses all possible outcomes. So if I roll a 6-sided die, the sample space, often represented by the capital letter S, is the 6 possible outcomes, the numbers 1 through 6. We can define events within the sample space. For example, let's let A equal the event that either a 1 or 2 is rolled. If we assume that we have a fair die, then all 6 numbers are equally likely, so we can use the third method of assigning probabilities to find the probability of A using this formula. We take the number of outcomes favorable to A, which there are 2 of, either rolling the number 1 or rolling the number 2, divided by the total number of outcomes, which is 6, since there are 6 sides to the die. 2 6 can be simplified to 1 over 3, or approximately 0.33 in decimal form. Next, let's discuss the complement of an event. The complement of some event A includes all events in the sample space that are not part of A, often simply thought of as not A. The complement is represented by the letter of the event along with a bar on the top, a superscript C, an apostrophe, or a variety of other symbols. Basically, if you see a capital letter with some kind of symbol on top or attached to it in some way, it probably means the complement. I will be using an apostrophe, or as some say, a prime, to represent the complement of an event from here on out. The probability of an event occurring plus the probability of the complement of that same event occurring is always equal to 1. Why is that? Well, because it's equivalent to saying what is the probability that event A happens or A does not happen. Those are the only 2 options. It's like asking what's the chance that it either rains outside today or it doesn't rain outside today. We are 100% certain that one of those 2 things will happen. Using some algebra, we can come up with a very nice formula that is used so much in probability, which is that the probability that event A does not occur, A complement, is equal to 1 minus the probability that A does occur. You can switch it around too, so you can find the probability that A does occur by taking 1 minus the probability of A complement. We refer to either of these formulas, but the first formula in particular, as the complement rule. So how does this work in practice? Well, remember our example of rolling a 6-sided fair die, where the sample space included the numbers 1 through 6, and the event A represented either a 1 or 2 being rolled. What is the complement of A? The complement of A contains all events in the sample space not part of A. This includes any number that can be rolled that isn't a 1 or 2, so that would be either 3, 4, 5, or 6. We can find the probability of A complement in 2 ways. One way is to use the same formula we used to find the probability of A, the number of outcomes in our event divided by the total number of outcomes. There are 4 outcomes in A complement divided by the total of 6 possible numbers to roll, which is 4 out of 6, or 2/3. Alternatively, we can use the complement rule. The probability of A complement is equal to 1 minus the probability of A. The probability of A is 1/3, which we found earlier. So 1 minus 1/3 is equal to 2/3, the same answer we got when we used the equally likely formula. Oftentimes, the complement rule can be used to find probabilities that would be extremely difficult or impossible without it. So always be looking out for situations where the complement is much easier to calculate than the event itself. In those cases, the complement rule will be your friend. Alright, my friends, we have finished our introduction to probability. We will be exploring many more fun and exciting statistical topics that you won't want to miss, so make sure to check out our other videos.